Okay. So what are now the deposits which can be used? You can use long wall mining, scattered mining, caving, wide drift, and what? Backfilling. Okay. Additional techniques can likewise be used. This includes sub-level stoping. So sub-level stoping can be used uh, in deposits now plunging from say 0 to 90 degrees. Did you get it? 0 to 90. Shrinkage stoping can likewise be used, no, for deposits plunging in the same range, 0 to 90, including cut and fill and what? Block caving. So again, as what was mentioned earlier, the considerations in the choice of mining method includes the geometry of the deposit, whether the deposit is tabular, irregular, can you follow? Okay, say ovate in form or mushroom shape. So that's a main criteria. In our case, because we are in the previous presentation, we are focusing on tabular veins, right? So we came up with three shapes, right? Three geometries, right? Regular, irregular, and tectonized for tabular deposits. However, there are deposits which are lenticular, right? Irregular, or in the form of what? I don't know, say elliptical deposits. Secondly is the geologic complexities. By geologic complexities, this involves what? Say the deposit, structurally controlled deposits which are what? Pinching and swelling type. Minsan kakapal, minsan ninipis because of what? Deformations, right? By folding. Probably you encounter this, no? Deformations by folding. Strains produced as a result of what? Tectonic and non-tectonic stresses, no? Oh, si Jason nagpakain? Oh. Yun.
To you.
Nagsishare ba ako dyan? Ha? I've already mentioned geometry, geological complexities, no? Especially in an area which is highly tectonized. So there are a lot of regions in the country which are mineralized. However, they are structurally
Sabi ka lang sa'yo. Sabi ka lang sa'yo. Sabi ka lang.
Sabi na lang, mabira na ako.
Control area.
Okay? So, so rock elites are folded, no? Folded, metamorphosed, and what? Okay? Subjected to various degrees of weathering and alteration. Okay? And of course, we have mentioned geotechnical properties of the country rock and ore body. This was already mentioned earlier. Can you follow?
Yes.
And depth below the surface of what? Extraction. So if you have a 3D model, you can capture all these parameters. Can you follow? You can easily describe the shape of the deposit. You can, of course, analyze the geological complexities. You can define geotechnical zones, right? And you follow. And you can obviously determine depth. And based on that, you may be able to estimate the amount of stress, right? You're going to estimate sigma 1, sigma 2, and sigma 3, and that's what? Applied mechanics. Diba meron kayo applied mechanics? Mechanics, meron kayo?
Yes.
Oh, strength, meron kayo?
Yes.
And in effect, it will be related to what? Rock mechanics, while Mark Pernito is currently handling applied mechanics. Can you follow? Saan nakikinig? So, of course, you have to factor in additional parameters like economic viability. Say, for example, 3 underground mining methods are appropriate. So it's a choice between cut and fill, shrinkage stoping, and what? Say, sub-level stoping. The question is how much will it cost if you use what? Cut and fill. Right? What are the benefits of what? Cut and fill as against what? Say, shrinkage stoping or what? Sub-level stoping. So you have to do cost-benefit analysis. Okay? Then, of course, there are also required infrastructures that you have to what? No? You have to provide, say, ramps. You have to provide access ramps, or you have to provide shafts, right? In order to reach your ore, including crosscuts and what? Drifts, right? Including dewatering infrastructures, no? Hydraulic infrastructure should be provided. As what was mentioned earlier, if the opening is what? Perennially wet, right? Okay? the opening will be what? Flooded and subjected to collapse. In some cases, like in the case of block caving operation, okay, you have to obviously consider several environmental issues that will be raised by people or what, say, farmers. A case in point is Philex. Philex is using block caving operation, and as a result, a lot of agricultural lands of the Benguet farmers are being affected as a result of propagation of tension cracks and creation of subsidence valves. Magsasubside yung lugar as a result of what? Block caving operations. Okay? Even geothermal steam extraction can obviously trigger subsidence valves. Can you follow? Papagsak yung ground. Did you get it? Okay, so you have to consider this. And of course, there are also engineering constraints, right? And you have to abide by several laws, Clean Air Act, Solid Waste Management Act, and what? Hazardous Waste Management Act, because you're going to produce as waste if you're going to treat your ore, right? Where will you dispose your what? Tailings. Yeah. So where will you, I don't know, where will you construct your tailings dam? As in the case of Mark-Upper, right? Diba? Nagkaroon ng rupture nung tunnel, nag-release yung tunnel ng toxic waste sa Buwak River. So those are the things that you have to address. Although there is still a sizable amount of deposit at Mark-Upper, pinahinto na because of what? Environmental problems and violations. Okay? So that should likewise be considered, that because you can expect high stress environment at the deeper level, especially at the depth of greater than a kilometer from the surface. I've been to a underground mine in Quebec, in Canada, whose depth I think is beyond 2 kilometers from the surface. 2 kilometers from the surface. If you're going to go to Philex mines, I think Philex mines is 1 kilometer from the surface. 1 kilometer from the surface. Okay. And they're using block caving operations. Okay? So grade is likewise considered, including geological complexity. Sino? Stop ko na to. Wala nang makikinig ng lecture eh. Sige. Let us greet Tessa. Happy birthday. Speech muna daw. Sige, Tessa.
Ito nga bang pag-games?